Hello and welcome to today's seminar in the Smart Mobility Connection series. My name is Carly Benhart-Kakula and I am the 2019 to 2021 Women in Transportation Fellow. The Smart Mobility Connection series is sponsored by the Traffic 21 Institute and the Mobility 21 University Transportation Center as an opportunity for faculty to showcase their current transportation projects. It is also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note this session is being recorded, and all participants' microphones are muted. To ask a question, please send a message through the chat box. You do not need to wait until the end of the presentation to send your questions. Now, I would like to introduce today's speaker. Justin Starr is an Assistant Professor of Mechatronics at the Community College of Allegheny County, where he teaches courses in electronics, mechanical systems, industrial controls, and applied robotics. He is also CEO of Janus Robotics, Inc., a startup firm using AI to enhance workplace and industrial safety through always-on machine vision. Before joining CCAC, Dr. Starr was the Chief Technology Officer of RedZone Robotics, a Pittsburgh-based manufacturer of teleoperated and autonomous underground inspection robots and decision support software. Justin is the author of the recently published book, Water and Wastewater Pipeline Assessment Technologies by CRC Press, and holds 7 U.S. patents for novel robotic and AI-based systems. He earned his BS in Engineering Science from the University of Virginia and his MS and Ph.D. in Material Science and Engineering from the University of Florida. Please help me welcome Justin Starr as he tells us about his University Transportation Center project using a virtual racing league to learn artificial intelligence autonomy as a skilled trade.
Hey, thank you so much, Carly. I hope you guys can hear me. I hope if you can't hear me, someone will say something. But let me share my screen, and I'm really excited to be working with you guys today. We're doing some really exciting things at CCAC, and I'm thrilled to, bring a little bit of that to this conversation. So you should see a slide that says AI as a skilled trade, with the title that Carly was kind enough to read for us. So before I begin, or while I begin, I'd like to pull up a poll question just because I really like interactive presentation and to hear from the audience. So if we could pull up poll number 1, I'd be interested to pick the brains of this crowd, right? So, poll number 1 gets into the heart of my presentation topic today, which is why we should even be teaching AI, not as a science or a discipline for advanced students, but why it really makes sense in the context of a skilled trade. So that first poll question, just do you think Tesla should be calling what they do autopilot? Is that an appropriate name? There's no right answer. Well, I mean, I have an opinion, but there's no right answer to that question. I just want to see where this Mobility 21 crowd lands on this. And we'll come up to those results here in a couple minutes. So like Carly mentioned, the title of my presentation is AI as a skilled trade, and specifically exploring how we can achieve teaching students the fundamentals of autonomy and artificial intelligence using a virtual racing league as a modality or as a vehicle to do so. So why I think that's important is I think there is a concept or a preconceived notion that AI is an advanced technology that should be the domain of computer science students, right? When people think of the skilled trades, they think of people working on motors and doing servicing for motor controls, or maybe HVAC technicians or electricians doing electrical wiring. And there's kind of a thought that, AI doesn't really have a place in that wheelhouse. So in this presentation today, one of my big goals is to change that paradigm, right? I fundamentally believe that we should be exposing students in the skilled trades to artificial intelligence, because it's going to be even more critical for them than it will be to those of us in other professions like professors, or maybe those of us who are leaving the workforce at the end of our career. This is going to impact these students' lives in a very significant way, and we do them a disservice by saying that this topic, can't be included in their curriculum. So it's absolutely critical. And one of the reasons why that's so important is, I'm at CCAC, the Community College of Allegheny County, and when students enroll in my program, I teach mechatronics, robotic technology, things like that. Many of them are coming because they want to get a job, right? They're looking to get a job that's going to last for the long term. They don't want something that's a 6-month engagement or a 12, they really want it to be the real deal, where they can support a family and build a career. And in Pittsburgh, we are very sensitive to the idea that automation is a disruptive force, right? Many of my students now, their parents or grandparents, know what it was like to work in the mills and remember how disruptive, the decline of that industry really was for the region. And I have other students who are in oil and gas who really recognize that industry can have this boom and bust, and layoffs are just par for the course. And so, whereas other people might say, well, automation is something you don't have to worry about, when my students in the skilled trades see a factory that's been automated by robots, they can see the writing on the wall. They understand that those robots replace the jobs of former assembly line workers, and they understand intuitively, in a way that's difficult to convey, how important it is to work with technology and stay in front of technology so that they don't become automated. So the number one reason why I think it's critical to expose students in the skilled trades, even if they don't have a background in upper mathematics or computer science, is because they're going to see it at work, right? So in smart mobility and transportation and not transportation, the companies where our students at CCAC are getting jobs are using AI on a regular basis. And it's not a technology of the future. It's not something they will be doing. It's something that's happening right now. So when students get jobs in these companies, they'll need to interact with these autonomous systems in some capacity. So just a couple examples of that. I had a student end up going to work for, I don't know why this ended up, skilled trade student, ended up working for Lemonade, the insurance firm, right? An AI-based insurance platform completely. That's a $3.8 billion company, and it's all artificial intelligence. There aren't agents underwriting policies. There aren't claims adjusters coming out when you make a claim. It's all done through software and artificial intelligence. And it's disrupting the entire model, right? $3.8 billion company with 18% margins, and students are working there, working alongside artificial intelligence. They're not coding the system. They're not developing the system. In a very real way, AI is their coworker. In another example that's a little more tangible in manufacturing, Tata Steel, right? We don't have very much of a presence with them in Pittsburgh, but large Indian multinational company with steel mills in Europe. Tata Steel started investing in AI, and they did so finding a 5 times return on their initial investment and improving their EBITDA by 13%. So they're getting more profitable without laying people off. In a very real sense, students who work in a steel mill that's experimenting with AI will see it as a part of their everyday life, even if they're just a worker, right? Tata's rolling this out to all of their mills around the world because it makes things more profitable without getting rid of jobs. So that's, key is learning to work with the system so you're part of the unaffected headcount. And we have students at CCAC who are pursuing their commercial driver's license, right? Getting their CDL in another one of our skilled trades. And XPO Logistics just came out with a really interesting case study about how they used AI systems with their local drivers to optimize routes in the face of the Suez Canal blockage, right? So that there are a bunch of on-the-ground changes they could make to optimize for those shipping delays. So a student who's getting into commercial trucking would need to be familiar with the fact that their system, their schedule could be changed or modified, not by a manager with day-to-day interaction with them, but by an AI system that's making these demands on the fly. It's a game changer. So if we want to prepare our students for entry-level jobs, we need to know they're going to see AI in the skilled trades, and they need to get familiar with it if they want to be competitive. This is another example I recently saw, is if you're familiar with AI, and I thought this crowd might be, right? You look at what they're doing with OpenAI or GPT-3, right? Elon Musk, working on this effort. This generative pre-trained transformer, it could speak its own blue in the face about auto-regressive language models. But what it's doing is it's automating entry-level jobs, right? You tell it, I want a table of publicly traded technology companies. It does it in Excel. It finds it. You want to do basic coding, shell scripting, or even some rudimentary Python, tell it what you want to do in simple language. It's what Wolfram Alpha should have been, right? It's writing copy and writing blogs, right? It got attention because the AI system wrote this blog post about feeling unproductive, right? It's not Liam Poor, that's a pen name, from scratch. Gave it a subject line. The AI wrote the entire article, and it was shared. It's so popular, it was a top link on Hacker News and got cited by MIT Technology Review, right? It's not a person. So to think that these students will somehow go through their career without interacting with AI, I think is disingenuous. I think it's happening. I think it's happening faster than we think, right? This is all stuff that exists today. It's not stuff that we'll see in 5 years or 7 years right now. The other thing that I think is critical, and let's look at the results from poll number 1 if we can, right? Not understanding AI can be really dangerous. And I saw the poll results come in. Yeah, we see them. About 70% of you guys here, and I think you can see it, think that the name autopilot is disingenuous and maybe not appropriate, right? I put the word disingenuous in your mouths, but many of you don't think it's appropriate. And I agree with that assessment personally. I'm not here to say if it's right or wrong, but the general public thinks AI is this, futuristic technology, open the pod bay doors, how, something like that. Without that real concrete understanding of how it works, it's dangerous, right? We, working in the future of transportation, understand what's going on with image processing and image detection and know what something like precipitation could do to our LiDAR sensors and the reliability of that data stream. If you don't understand how it works, it can be deadly or detrimental, right? If you think AI is something magical and you trust your Tesla to drive by itself and take your hands off the wheel, and you very quickly can find yourself in an accident, right? And so why I fault Tesla for that is when we name something autopilot, if someone educates themselves on the system and they read the documentation, they understand exactly what it can and cannot do. But if someone doesn't take the time to get that education, they're left thinking this is something that actually drives itself all the time, and that can be dangerous. So for students who are pursuing careers in mobility or in transportation adjacent industries, doing this kind of stuff at work, knowing how AI and autonomous systems work and make decisions is critical to troubleshooting effectively and using these systems in a way that you can be productive. I believe firmly that our students are going to be at the nexus of human AI collaboration, and knowing how it works when literally your coworker is a cobot, controlled by some algorithm, is critical to working safely and effectively. So the next reason number 1 is that students will see it at work. Reason number 2 is not understanding it can be dangerous. I want to get into the third reason why I think it's so important we teach AI as a skilled trade. And if we could pull up poll number 2, that would be fantastic. And poll number 2 is recent feedback that we've gotten from, I would say, someone who is deeply involved in the skilled trades, right? Trane, HVAC, huge manufacturer of all of that equipment. And my question to you in the poll is, they just launched a new certification program. And what was that certification program that they launched? Were they looking at refrigerant discharging? Was it an HR course on working for AI manager? Was it data analytics? Was it capacitor replacement techniques? I know you have no way of knowing the answer to this, right? I'm just curious, what do you think an HVAC company is focusing on actual training for technicians coming into the program today? And this is interesting. I get to watch the results, right? So interesting. No one's picking refrigerant. I would have thought refrigerant. No, it's okay. I don't want to ruin it. So why, I'll leave the poll up while I kind of speak to why this is so significant, is when you look at this request that Trane is making of their new and incoming employees, it reflects a broader trend in the field of artificial intelligence, right? And that broader trend is that if we go back even 6 years, it used to be clean 5 years, but I've been hanging on to this slide for a little bit too long. It has evolved significantly. So if we go back to 2015, when many of us last thought about AI, or many of us in industry last thought about AI, what was it? It was the focus was on algorithms and proving that AI could beat people, right? 2015, CMU, our valued partner, is entering an AI system in the World Series of Poker. Show what it could do, right? In 2015, it's not until June that Amazon releases our beloved, our hated Alexa system, right? Alexa, now a part of our lives. Fast forward to 2021, right? AI in industry is not like that. AI has matured so much so that users are able to get free toolkits and framework, open source abilities that they don't have to write the algorithm for. They know that by using it, they can produce business intelligence on demand. So in 2021, right, AI is focusing on applications that impact business success. You can be a competent AI developer, right, as frightening as that term is, by stitching together existing frameworks to make something cool, right? If you can read the documentation and go to Stack Exchange, you can use AI to transform business intelligence, right? You get an NVIDIA Jetson with the built-in libraries for $89. You can have a teacher with no experience making an attendance tracker that uses facial recognition. You can get YOLO version 3, right, to do object detection with 10 lines of code. You don't have to know anything to start using AI, but you do have to start knowing data. And so why it's so important to teach this is, when we go back to this poll, and let's share the results again. Oh, I can click share, right? Yeah, I fooled you a little bit. Train wasn't looking for AI-based managers. They're looking for data analytics with Tableau, right? They want HVAC technicians to get a certification in data analytics, knowing that in the data science hierarchy of needs, if you're going to understand AI, you need to understand data first, right? And that blew my mind. Like, can you imagine when the HVAC technician comes to do a repair and they start showing you a Tableau dashboard, right? They have their traditional training courses, HVAC, automation, chiller, refrigerant, whatever, but they're going to bring data analytics to the game, right? That's transformative, and that's huge. And to think that incoming HVAC technicians are going to be up to speed on data analytics is, I use the word transformative too often, but it really, truly is. So when we look at the 3 reasons why it makes sense to teach AI in the skilled trades, to me it's self-explanatory, but a lot of people look at me kind of funny when I say that. So I hope I've at least convinced you guys that it's worthwhile to some degree, right? Students are going to encounter it at work. If they don't know it, it could be dangerous, and employers are already requesting it, right? They want their students to come in knowing AI. So, okay, so AI is in demand. How do we teach it, right? How do I take a CTE program, right, and effectively bring Alexa into it, right? I tried asking this morning, it didn't work. She ended up ordering something. Alexa still has some kinks to work out. But I mean, it is not trivial, and it's even less trivial when we look at what's going on with COVID right now, right? So we're working remotely. How do we bring AI into this? We don't really want people clustering if we can help it. And so to give you a sense of the challenge we're facing, right? How do we bring AI into this? Let's pull up the 3rd poll. If you had to ask yourself, right, what are the biggest challenges in introducing AI tools and smart mobility to students, especially in the skilled trades, what do you think those hurdles are going to be? Is it going to be they just don't care? They're not interested? Are they not going to have the computer chops to do so? Are they going to feel excluded from AI because of some gatekeeping where the industry says this isn't for you, it's for the rocket scientists? Is the documentation bad? Do they not have the math to understand? What do you think is, the biggest hurdles? What is the biggest hurdles? My grammar. What are the biggest hurdles? You only pick one, though. You got to pick one. That's the catch. And so while we kind of vote on that, what we started to look at was, I think we took it as an assumption that students were going to be interested in AI, right? Like, they might not think they could do it, but everyone's a little curious about what makes the droids in Star Wars talk a little bit. So you keep voting. We'll show the results in a couple slides. But we thought a way to get people interested in this is to use racing as a convenient entry point, right? Because everyone, not everyone, but a lot of our skilled trade students like machines. They like fast machines. This is a way to kind of get to them, right? So rather than say, well, here's an academic treatise about AI, if we say, we could use AI to do something with racing that's interesting. Because even if a student isn't racing themselves, maybe they're interested in automotive, engine building and tuning to make things go faster. And locally in Pittsburgh, right, they all have some exposure to autonomous vehicles because we've got Uber, Argo, Aurora, all in our backyard, active, doing stuff. They see them. Some of them may have even been involved in a self-driving Uber, right? Further, we've got a lot of them looking to go into the automotive industry. They'd love to go work for the big three. If they continue their studies and go into engineering, some of them want to go to dealers and, repair cars and work as trained technicians. So, whatever we do, if we do racing and there's some kind of tangible skill, learning about sensors and data streams, this can help them and it can really go a long way. And if I share the results of this poll, which I think I just did, it's a trick question. You're right. Everything was a hurdle because some students truly thought AI wasn't for them. Some students didn't have the computer skills to get started. They didn't believe in themselves. And where we think, people working in the field of autonomy and artificial intelligence, this system's so easy to use, it's appropriate for an end user. We fool ourselves with open source tools all the time. Oh, my parents can use Linux. All right, let's see how that works out, right? Same thing. There are these great toolkits and great frameworks, but they take a lot for granted, right? They take a lot of command line abilities for granted. They take Python for granted. They take this basic sense of understanding data structures for granted. None of that is there. What we did find is that students find math to be something they're afraid of, keeping them away from AI. But we actually didn't find math to be a problem. So that's interesting. So the model we went to, so we're working remotely, we want to do something racing, is we found a system that used a device called the donkey car. And the donkey car is an open platform for vehicles that can either be controlled directly or can be driven by some kind of autonomy. So the idea is there's this RC car platform, this chassis with a Raspberry Pi or a Jetson. I prefer the Jetson that you can code to, looks kind of rough, do some autonomous driving. So students without a ton of training can actually make a car. They can teleoperate it if they want. They can record a bunch of data as the car drives around and use that data to train their own neural net pilot. So the goal is they don't have to develop the entire autonomous system. They can buy this kit, and with a small investment of time, think a couple of hours to build it, a couple of hours to load everything onto the Raspberry Pi, understand the documentation at an end user level, they can start driving and gathering information. So it's a way to ease them into this idea of smart mobility and autonomous systems without starting from, well, here's what a convolutional neural network is, and let's start taking apart these layers. It's very approachable and it's very tangible. And the goal is, have them race against each other. Competition motivates people to do great things. Funny, the donkey car name, I always wondered why they call it that. Is it like a Donkey Kong pun or arcade thing? And the open source group says, actually, donkeys are one of the earliest domesticated pack animals, safe for children, occasionally don't follow their master's commands. So if you ever start programming an AI system, it's a good fit. And then funny, they have this transparency. I'm going to say donkey has a negative connotation. So expectations for the platform are low. They worried if they called it like the Eagle car or the Mustang, people would expect this slick experience. But I guess they figured you order donkey cars, you're not going to have any kind of high expectations for the process. But so, okay, donkey cars are great. Let's build cars and race them, but we have COVID. So how do we do that, right? Are we doing classes in person? Yes, but essential classes, right? If students need to pick up hands-on skills in the lab to do their job, like for me, work on a robot, or for my colleagues, work on a mechanical system, HVAC, engine, they have to come in to do that. But it's sort of disingenuous to bring students in to do remote control racing. It's not the right time. And we'll get there, right? This pandemic's lifting. We're all getting vaccines. The end is in sight, but it's not here today. So it's not a good place for us to start. So the other benefit of Donkey Car is they're part of a broader platform where they have a nice simulator. And the simulator is Donkey Gym. And Donkey Gym is an open AI wrapper with a self-driving sandbox. It's all Unity, so we don't really have to worry about physics and graphics. So it effectively lets students replicate the donkey car system in a simulator. So they can build effectively the same car and drive the car around in a simulated environment, collect data, make neural net pilots, and effectively drive it in the same way. But it's also hosted on a server that we can establish local or internet-based connections to. So once students train their neural net pilots, they can actually race them against each other in structured events. So we can have students spend some time building a model, collecting data, optimizing it. When they think they're ready, they can upload their neural net pilot, and we can have a structured race where the pilots go against each other. There's multiple tracks. There's a race admin tool right out of the box. It's actually kind of nice to use for an open source tool with very difficult user interface experience, right? So this is the idea. So we figured, let's start with this simulated platform because we have COVID. And actually the beauty is it translates easily, almost one-to-one, onto the physical donkey cars. So we could make a campus-based racing league with students at our various CCAC campuses, training their own neural net pilots, training them from home, and bringing them all together for a racing event, which would be a nice collaborative community building thing. So this is the idea of it. Even if we can't get together right now, it's a good way to get students involved. So we tried it, right? In fall 2020, we tried it. And we had a couple of pieces of equipment that were pretty old, but they got the job done. We found a switch port on the network that no one was really looking at. And then I happened to be teaching a class of mechatronics apprentices, so I had a captive audience, right? They had to be with me for class, so at least part of the class time I could devote to having them try this virtual racing league. And so the idea was we weren't going to spend a whole day on it, but we put together a curriculum, we put together a boot camp, so we start getting the students up to speed with the program and see what it was like. So this was either going to be great or it was going to be a disaster, and these guys were the guinea pigs, whether they liked it or not. So we made our own little server thing, and believe it or not, they kind of took to it, right? They got really into it and gave us some valuable user interaction data. It wasn't perfect. We learned a lot of flaws along the way, both with how we thought the students would take to the system and with the background they need to be successful. But we had a class, mechatronics apprentices who'd never done any computer programming before, had never used Linux, thought Python was a snake, right? That's their frame of reference. And they're training their own models in these photos. And I'll show you a video in just a second. So our expectations for this, right? We put together a curriculum that really helps students understand the context of AI. So not so much what are the details of what this system is doing, but why is it doing it and why is it important? So the context of AI was one of our paramount goals because, again, we think students are going to be using this on the job. We have some pretty good data to support that, but there's also a nuts and bolts logistics piece. So the little boot camp, we got the students up to speed using the Donkey Gym platform, editing their configuration files, and training neural net pilots with the context of I know what I'm doing to some extent, right? I'm collecting data. The data is going to use AI to make decisions. It's going to race, and I understand basically the flow of how that's working. And so it's a mixture of this high-level conversation about AI paired with some of those technical skills that are needed. And this, I think, is a big skill gap right now, right? We think students today, even in skilled trades, they all know computers, right? Because my niece grabs my iPad and does all this stuff. They know computers, but they don't know computers in the way that they need to use these off-the-shelf AI toolkits, right? To use these tools effectively, even if you're running on Windows, you need to have some knowledge of the command line. You need to have some knowledge of configuration files, and dang it, if Linux isn't helpful, you know, because even when things run on Windows, they've usually been ported there. So if you want to get the pathing right and you understand Linux, it's just so much easier. So we really tackled it from both ends. High level AI, low level, let's give you the skills that you need to do something like clone a repository to a folder and start editing some files, right? There's some nuts and bolts conversation that's needed to be productive. And the idea was maybe by the end of this session, we'd have them racing. So just a little video I took of students actually engaging in this. So I had one of them on the projector and I just recorded the screen. And they get it all working. They show it in a browser. And this is how they start training their data, right? So they're driving around, altering the throttle inputs, controlling it with this little bit of a janky keyboard. I mean, but we had success, right? Students were driving a simulated vehicle in an environment, looking at the sensor data that was being collected from that vehicle, cleaning the sensor data after it was collected, and using that to train a AI system, a neural net pilot that could actually drive. So the next poll I want to get into, poll number 4, is how long did it take students to do this, right? I'm not saying how long did it take them to become experts, but how long roughly did it take for them to get to this level where they get something up out of the box, they're running, they're collecting data, they don't know anything about command lines, so we're teaching them that along the way, couple minutes, couple hours, days, weeks, and then the last one's just a joke. But I kind of think that sometimes, right? I know even when I'm good at something, I can always get better. Students don't realize that yet, but they will. And you guys are pretty much right on this poll. Everyone who's voting, well, not everyone. So everyone who's voting, I think we have a range of responses because what does proficiency mean? It actually could have a more complex meaning. But for students to get to the level where I showed, where they cloned a repository, edited a config file, got something to run, and were able to control it through the browser, they're able to do that in a time frame that's very close to what you guys predicted. Our number one vote was 4 hours, and that's about what it took, right? We spent about an hour configuring the environment and getting that up and running, and I'll hedge by saying, I don't know if they're proficient in that, but we got through it and they got it running, able to train models in another 2 hours, and able to deploy their neural net pilots at the end of what I call a 4-hour crash course. I say no pun intended, but pun fully intended, because they crashed all the time. So the idea there is we didn't train them to be experts, but in 4 hours, they went from thinking AI was something in a vehicle that they'd never be able to use to actually being able to run those systems. And these are some videos of the actual apprentices doing it. And I think I took the sound out. I hope I took the sound out because they don't always use great language when they're raised, but I mean, they're doing it. And they recognize they ran into something. I'm going to have to clean this data, take these, like they were doing a great job with just 4 hours of training. Now we can always do better. We can always keep going. But I mean, that was it, 4 hours and they're doing this, which is something we were surprised about. And they're having a good time doing it too. So really, really, really interesting. Yeah, videos, real students. So, what does this mean and what are the outcomes from this? I always try and make it a little bit quantitative whenever I can, and I'm not always able to do that. But, some of the outcomes we saw is when we polled the students after the experience, overwhelmingly, it's only a class of 10, so we're not at the level of statistical significance, but they have an increased appreciation for AI and they understand it on a level they didn't have before. Some of their actual quotes, right? I kind of understand how my Tesla works, whereas before they didn't. I see how a trained model could be useful at work. I think I could use similar AI tools in my day-to-day job. Unsolicited, free-form student feedback. This is what they're coming back with. This is a leading question. Would you be comfortable? Would you not be comfortable? Yeah. I think after this 4-hour crash course, I could set something up like Donkey Gym and interact with it. I'm not comfortable writing it, but I could use it every day at work. And all of the students found that the racing simulator was at least somewhat effective, right? 100% of them said it's somewhat effective at teaching the principles of AI. 80% of them, though, said it was effective, right? Not just somewhat effective, it was effective. And one of the hands-on comments, right, much better than some kind of lecture. Actually doing it gave them the appreciation for how that was working. The students also identified the gaps in their knowledge in the same way that we did, right? They said, I wish I knew more about computers. I need to get some knowledge there and I'd get much more out of this. If I knew a little bit more math, I'd understand some of these transforms. Can I take a class on programming or Python? Interesting, I had someone who thought they were going to do CS and they had a background in Java, but it wasn't helpful, right? The object-oriented framework, they understood the context, but just quick and dirty scripting was something they got an appreciation for. And then you love to see these connections at work, right? Do our AGVs work similarly? Were they trained in a similar process? I don't know, but the fact that they're asking these questions is phenomenal. And we got some students to convert to degree programs, right? Not all of them, and they're kind of weird in that they were being sponsored through an apprenticeship program and their tuition was covered. But I mean, some of these students were students who said, I'm just doing this to get the raise at work. As soon as I'm done with school, I'm never going to do school again. And 4 of the 10 students who attended the AI bootcamp went on to enroll in classes in their associate's degree. So I'm not saying that the AI racing program is the cause of that. I'm saying it's an interesting link that 4 out of 10 of those students converted, which is higher than we see in students who didn't go through the program. So I'm not attributing it to that, but I think there's something here about sparking learning that we want to dig into in some more detail to really get involved. So one last poll, right? So when we did this, we didn't get done. We didn't finish in time. And students were able to train their models. I gave them 4 hours and then class was over. They didn't have to stay. How long did they stay? To keep racing after the fact, right? We didn't have time for the race. So sort of anticlimactic. So how long did they stay afterwards? Did they just book it? I didn't give you that option, but 5 minutes would be they just booked it. See you later, teach. I'm done with your fancy computer system. And yeah, it's a pretty good poll response. I wish we had to kick them out. I love to see that. I love to see, oh, we had to kick them out of the lab. It wasn't that. It was good, but it wasn't that good. They stayed for about 2 hours, right? And they wanted to race each other. So the thought that this racing league was going to motivate them, I think was proven to be successful, because when we didn't get done, they stayed and stayed and stayed so that they could get a race in, and worked on refining their models until the race was actually somewhat successful. So 2 hours, voluntary time, not part of their class, on a Friday where they could have gone home, and they elected to stay with me, something I didn't expect to see. So, you know, what's coming next? We've got some exciting things. I'm talking about results from the fall. We've been putting together a curriculum to get ready for the spring, and we do it at the end of the semester. So our next cohort, we're going to try, learn from our mistakes, and run the 4-hour crash course again and see what we learn end of April. Different apprentices this time. We are looking at building out a virtual racing league. So we work with student events on campus to send a mass email to student groups about joining a virtual racing league. And we have 3 mechatronics students right now working with a mentor from Seagrid locally to put together a training program for the student groups who are interested. So the goal would be to launch a campus racing leagues by training student groups so that they can get involved in this competition, but give them the tools to be successful. We don't want to be like, well, download Donkey Gym and follow the instructions. We want to give them a step-by-step framework to train a model that'll make for an entertaining race. So we're hoping to pilot this with a couple student clubs over the summer semester, but we'll see what things happen. Everything's so weird with COVID, and enrollment's kind of funny. I don't know. That's the goal. It may get pushed into fall, but it's really nice to see the mechatronics students and the mentor voluntarily working on making this training program. And then we're also looking at revising our Intro to Technical Computing class. That's part of our Engineering Technologies program. And it was great, but I think the skill gaps we identified need to be in some kind of formal program. So we're going to modify that in the fall. So we cover Linux, scripting, some basic Python, so that students get that technical computing foundation that they need to really be successful using some advanced tools like this. So I see the question. We're not working with any racing league right now, but if anyone wants to sponsor, I'd slap some numbers and some decals on these virtual racers, no problem, right? I'm not a big Unity person, but I'll figure out the skins, right? We don't have Bubba Wallace on board, but man, if he called me after this presentation, I'd take the call, that's for sure. So I conclude that this is effective, right? I firmly believe we need to get AI into the skilled trades, and this virtual racing league is an effective vehicle to do so, right? The Trojan horse, get them excited about racing. They learn something about AI along the way. We've seen it's meeting our goals in terms of expressing student interest in AI, and added bonus, students are continuing their study here. So I think that's fantastic. We know we need to do better at tech computing, and that's going to help us across the board in the skilled trades. So I know I had a time target, 30 to 40 minutes. I count like 39 minutes. So I want to make sure we have enough time for questions. I absolutely want to thank Mobility 21 for giving us the support to do this. And if you're interested in our curriculum or you want to help out, my email's here. I love working with other schools, other institutions, other people. Please just let me know. We'll share what we're working on. No problem. We'd love to get your insights. So any questions, any comments? Love to have a discussion. NASCAR is desperate. It's actually been interesting too. So with the racing being virtual, that actually helped with interest, right? The virtual, right? They're actually racing on video games now. So that helped us get a little bit of interest. So when we thought about other vehicles for introducing AI, I mean, we have some good robotic systems. We have, or in the process of setting up some sensors that we see on self-driving cars. So the thought was, you know, do we build something where we start with sensor data as the inputs and kind of build up to AI from there? But I think the car and the racing program, it just had this holistic idea that made sense. So I'm reading questions that are coming in from the chat. People are like, what are you talking about? So someone said, what other vehicles did you consider? And I think once we landed on the car platform, it was a no-brainer. We'd looked at working with the donkey cars and other cars for a different experimental course, also sponsored by Mobility 21, but the pandemic got in the way. So we had some institutional familiarity with the platform. You know, I knew it kind of well. And just the idea of starting with something holistic was very appealing rather than starting with sensor data and working the other way. So going back to the physical car, this is what we're excited about, right? So we train those neural net pilots and then we can deploy them on the donkey cars. So we could conceivably have a program where students can perform in virtual races and race their physical cars, so we could host an event on campus where maybe we do outreach to high schools and high schools can work on training their car and they all come for a race day and we see who wins. You know, they could do the initial race, tweak their model, come back, do a follow-up race. And meanwhile, they could test it in simulation so they could be racing against others by seeing the times other groups are doing without orchestrating a giant event. So I think, you know, we're really pleased about it. I think the link between virtual and physical, I don't know, ask me in a year when we actually try and deploy it on the physical cars. Right now it's an idea and it seems to work well, but I mean, there'll always be logistical and scaling concerns. Another question, was it difficult, time consuming for the Unity simulator? Yeah, I mean, yeah, it was. I mean, the nice thing is it was Unity, so we didn't have to worry about physics and graphics. There was a lot that was working, but to get it working reliably over the network was a challenge for us. It's working in a great place now, but I'm just reflecting, trying not to paper over it, thinking this is all great because it's great now. There are some days where it's really a struggle to get everything working, especially simultaneous connections from students and the GPU overhead. I cheaped out, right? I bought the cheapest GPU I could find because I figured the garbage server, but we really did have to upgrade it to get the performance we wanted. So that was eye-opening for me. So maybe a little more optimization would help, but there's a lot going on. Any other questions or concerns, comments? Maybe not concerns, questions or comments. I think I got through everything in the chat. I see some comments on sponsorship. NASCAR is desperate. Hey, I'm in. If you guys can get NASCAR like 100% in, just I'll give you my phone number after this. I'll give you my phone number now. You know what I mean? Have them call. We'll take the money. That sounds great. If there aren't any other questions, just shameless plug. In the beginning of my intro, they mentioned my book. Pre-order now. It's on Amazon. That would be great, right? Totally shameless plug. If you guys would pre-order my book, that'd be fantastic. Oh, good. We saw some questions after I went to the shameless plug. Problems with scaling this up. So I don't know. And there's a lot that we've been blessed with at CCAC because we're able to test this on our campus network. So we don't have the latency concerns that we'd have from using the public internet. So scaling this up and actually doing like a virtual race with high schools scares me a little bit because I know I'm not big into online gaming, but I was. I mean, back when the internet was not what it is today. I know that lag and latency could really have a UX problem, right? So we upload the models and the race happens in real time, but if that's not having performance for students, you know, that's really disappointing and we don't want to have that outcome. And then what types of transportation jobs? I think the idea is, well, one, direct outreach. We had a student who worked with us on this who went to get a job at NREC working with VU, right? And VU's outreach group and his training and his education group. So one, direct link to what they're doing, reaching out to schools to do interesting things with robots. So 100% in terms of jobs, going to work at NREC, doing outreach to schools, setting up competitions, that's a no-brainer. I think if we take this where we want to take it, students will learn enough about working with the NVIDIA Jetson, basic programming on that embedded system. This will get them ready for. And then the goal is in transportation, whenever they're working with autonomous systems, even if they don't go on to work for, Uber or, GM making these vehicles, just understanding and looking at the feed of the sensor data and seeing what happens when that feed goes wrong as applied to an autonomous system, I think will make them better users of those autonomous systems, better technicians for those autonomous systems, and they'll just get it. You know what I mean? It's sort of like when something goes wrong with the system and someone's like, that's just cosmetic. But the people who really know start freaking out because they know about the unintended consequences. You have someone say, well, it just uses the radar for adaptive cruise control, or it just uses that camera for convenience. To understand what those occlusions do to that data, I think is going to be key to students becoming successful transportation technicians, right? What types of jobs can CCAC students get at autonomous vehicle companies? Any idea of salaries? That's a great question. So the reason I went to CCAC and started teaching in the first place is so I used to be the CTO at RedZone Robotics, which we made water and wastewater inspection robots, hence the book. And we struggled to get talented technicians, right? We would want to get junior technicians to do electronics work, to basically flash some FPGAs. We had an autonomous sewer robot, so they'd have to understand a little bit about how that worked to troubleshoot effectively, and it was difficult. So my goal in coming to CCAC was to help make programs that would let me, if I could go back in time, hire some of those people I was so desperately looking for. So I think CCAC students end up at the autonomous vehicle companies doing some of their testing of some of their custom board design, doing operational testing, being in the vehicle while it's driving, working with those systems, repairing those systems, doing acceptance testing when they get a bunch of custom boards in, making sure those boards work the way they're supposed to with the sensors in the system. It's all about that hands-on experience and even working with the full system. So I think the jury's still out on that because we're just making these strides and the autonomous vehicle companies are doing so many interesting things. It's changing so quickly. But the goal would be for students to be technicians there and even some of the drivers working with the cars. I don't want to say test engineer because engineer has that connotation, but test technician working in the full system, looking at the systems integration, our students would absolutely be qualified for that. And some of them I think would be great at it. So yeah, Bob's mentioning too, we're also really excited to be working with the Department of Transportation to get the connected autonomous vehicle in a box system where we can take this technology that we really whipped up ourselves with a simulator and some free time and deploy it to a standardized platform for connected autonomous vehicles to really look at how these systems work with intelligent transportation systems. So we're super excited to pilot that. And all of this, like nothing is perfectly complementary, but this effort is designed to dovetail into that program with the connected autonomous vehicle in a box or cave in a box system. So we think even more will come from this in the future. What's exciting to me is some of those students who went on to do their associates, taking those data analytics courses, right? Going from knowing nothing about AI to seeing it's approachable, to working with Python, to actually getting some training there. I mean, this is what makes them marketable in today's economy. And, one step at a time. We're always looking to make them better and looking to build that data fluency. When questions come in, I'll answer the questions. But if there aren't questions, I'm just going to leave the shameless plug up there, right? I'm just kidding, kind of. But the link works. Any other questions, comments? We're so excited, and we're grateful to Mobility 21 for making CCAC a part of this conversation. I think, my passion is about thinking of ways to convey these topics in a way that's, pedagogically interesting and significant. I'm not the kind of person who does cutting edge AI research. I mean, you get that from me in this conversation, but the idea that we can deploy this and we can get students using it, that's what gets me going. So we're just so thankful for the collaboration. It's been great to work with some of those four-year institutions and find ways we can collaborate. So this has been really helpful. Students entering CCAC courses with a good working knowledge of this technology, no, is the answer, right? We find students who come in, if they're exposed to this at all, they've maybe done first robotics in high school, which is not the same as this. So the idea of autonomous systems, it really is the empowering thing, the thing that gets me, a tear to my eye, is they think they can't do it. They think this is beyond them. And then they see that programming and configuring an autonomous system is something that's within their wheelhouse and their capabilities. That's it. So no, they come in thinking this is magic. I'm never going to be able to do this. I'm, just working on my skilled trade. I want to do my apprenticeship. And then they understand that this AI revolution absolutely can include them. It's not going to leave them behind. They have what it takes to work with these systems. So that's a great question. Any other questions? I think I got them all. If I missed one, just tell me. Yeah, Chip Ganassi, give me his number. Let's get him in. Bubba Wallace, let's do it. I'm in, guys. I love it. Formula One, they've got money, right? Let's take Formula One money. I mean, I don't like Formula One as much, but that's not the point of this conversation.
Thank you, Justin, for sharing your work. And to all of today's attendees, thank you for joining us. As I mentioned earlier, today's presentation will be posted on the Mobility 21's What's Happening page of the website, along with a link to the video of the session. This afternoon, you will be receiving an email asking you to take a short survey about today's SMC. Please take a few minutes to provide your feedback. For students who are interested in engaging transportation topics, the Transportation Club on campus is a great way to plug into transportation topics with fellow transport nerds. Our final SMC of the spring 2021 semester will feature Umit of Ohio State University and will be held on Friday, April 23rd. Watch for your invitation to join us closer to that date. Again, thanks for attending today and feel free to contact us with any questions.